Hello everyone and welcome. Today we're continuing with our discussion on Organic Chemistry 1, where we're looking at formal charges. And this is presented by Science Visualized. What are formal charges? These are charges that are placed on atoms when they have bonds above or below their valence. That means if the number of bonds that the atoms have are higher or lower than their valence. There are two formulas we're going to be looking at. The first one, formal charge equals to the number of valence electrons minus the number of electrons that that atom has. Number two, this basically just focuses on the number of bonds. The formal charge will be positive if the number of bonds is greater than the valence, and then it will be negative if the number of bonds is less than the valence. So this gives us this formula. Formal charge equals to number of bonds minus the valence. Let's apply this. The first example is water, H2O. If we look at the oxygen, that one, it has two bonds, so 1 and 2. So the number of bonds is 2. If we go to the periodic table, you'll see that oxygen is in group 6A, meaning that it has 6 electrons in the outer energy level, but it only lacks 2 electrons to make 8, so it makes 2 bonds, so it has a valence of 2. So the valence here is 2, then it becomes 2 minus 2, which gives you 0, and therefore the oxygen in water has no formal charge. Next, hydroxide ion, HO. This oxygen has 6 electrons, so 3 pairs. If we look at that oxygen, the number of bonds is only 1, and the valence of oxygen is always 2. Applying that to the formula, number of bonds minus the valence becomes 1 minus 2, which gives you minus 1, and therefore the hydroxide ion has a charge of minus 1. So usually we don't show the 1 unless it's number 2 or 3, minus 2, minus 3. So if it's just 1, you just leave it as a minus charge. And that's why you will see hydroxide ion written as this, HO minus. Sometimes people write it as OH minus. That's misleading because the minus charge is not really on hydrogen, but it's on oxygen. Let's look at the next example where we're looking at hydroxide ion, but now we are applying the first formula here. Formal charge equals to valence electrons minus the number of electrons. So for oxygen, we just saw that the valence electron is 6, and the number of electrons around this oxygen is, we have 2 here, 2 and 2, so that's a total of 6 electrons, so 6, plus for each bond, oxygen contributes 1 electron, so plus 1, that gives you 7. So valence electrons for oxygen is 6, minus the number of electrons for this oxygen is 7, and that gives you minus 1, which actually agrees with what we saw before. So it has a charge of minus 1. Next example is what we call hydronium ion. That's like water with an extra hydrogen or extra proton. That oxygen has only one lone pair of electrons right here. And if we plug in the values to the formula, formal charge equals to valence electron. For oxygen, valence electron is 6 minus the number of electrons around this oxygen. So for each bond, oxygen contributes 1 electron, 1 electron, 1 electron. So that's a total of 3, and then plus these 2 here. That makes a total of 5 electrons. So then the answer becomes 6 minus 5, which gives you plus 1. And therefore the hydronium ion has a charge of plus 1, and you'll see it written as this. In the next example, we're looking at the formal charge of nitrogen. And if we look at the periodic table, nitrogen is in group 5A, meaning it has 5 electrons. So the valence electrons for nitrogen equals to 5, but it needs 3 more electrons to form an octet, to form 8, and therefore the number of the valence of nitrogen will be 3. So let's plug these values into the equation. We see that the number of valence electrons for nitrogen is 5, minus the number of electrons around this nitrogen. It doesn't have any electron pair, but it has 4 bonds. So for each bond, you have 1 electron for nitrogen. That's a total of 4 electrons. and therefore it becomes 5 minus 4, which gives you plus 1, and therefore that is an ammonium ion. And it has a charge of plus 1. Next, we're looking at this carbon here. We're trying to determine its formal charge. And again, we use the formula, valence electrons minus the number of electrons. We know that carbon is in group 4a, therefore the valence electron is 4. And then the number of electrons around this carbon, it has 3 bonds. So for each bond, you count 1 electron. So that's a total of 3 electrons. 4 minus 3 gives you plus 1. And therefore that carbon has a plus charge. And that's called a carbocation, where you have a positive charge on carbon. Next example, we're looking at a formal charge of this carbon. Just like we saw before, the valence electron of carbon is 4. But in this case, the number of electrons around carbon, we have 1 and then 2. And then for each bond, we have 1, 1, 1. So 3 bonds gives you 3 plus 2 gives you 5 electrons. 4 minus 5 gives you minus 1. And therefore the charge here is minus 1, and that's called a carbanion. It will be CH3, C, CH3, H minus. Next, number 6, we're looking at water, which has 2 electron pairs. So if we look at that oxygen, its formal charge will be valence electrons, which is 6, minus the number of electrons around that oxygen. We have 1 for each bond, that makes 2, plus the 4 electrons, lone electrons, that makes 6. So 6 minus 6 is 0, and therefore the oxygen in water has no formal charge. The last example, we're looking at this nitrogen here. So the formal charge for nitrogen equals to valence electron. Nitrogen is in group 5a, so it has 5 valence electrons. And then the number of electrons around this nitrogen, for each bond you have 1, which gives you 3, plus this 2 here, that gives you a total of 5. 5 minus 5 is 0, and therefore there is no formal charge on this nitrogen. And this is called ammonia. Thank you very much. If you enjoyed this presentation, please consider supporting this channel by liking this video and also by subscribing. Thank you.